All right, Math 8 peeps. This is Wednesday, and we are in the mix or the end of October. It is October 27th. So this video is kind of long overdue, as you can see above. I had this scheduled for the 19th, but today we're going to talk about combining like terms, and this is our review video on that. So, like terms is one of those things that kind of helps you solve equations. It helps you kind of break down or bring together a big mess of terms. So let's first start off with what are like terms. Well, like terms are those terms with the same variable. And hopefully in this video you'll get a better idea because I'll bring some practical or real life examples into the game. So if you look at this picture here, you can see how they broke down what the like terms are. But we're not going to talk about the algebra part of this yet. We're going to talk about more of the real life aspects of this, so to speak. So if we scroll down examples, so we have Miss McKeachik, right? So if you guys are familiar with Miss McKeachik, which you all are, as a math teacher, you can understand that her main crush is John Krasinski. So he's the main actor in The Quiet Place. If you've ever seen it, you've seen pictures up all over a room. Now, you're probably saying to yourself, what does this have to do with like terms or combining like terms? Well, this is not going to make Miss McKeachik very happy, but here's the bottom line. Krasinski from Quiet Place, the actor, and Miss McKeachik, they can't come together as like terms. Okay? They're two separate terms. So what does that mean? That means if we were to combine like terms, Miss McKeachik would be her own set of terms, and Mr. Krasinski would be his own set of terms, and they would be separated by what we call an operation. So if we wanted to add them or subtract them, we could do that, but it would be like this. So how many Miss McKeachik pictures do we have? We have 1, 2, 3, 4, 5, 6, 7, 8, 9. So if we wanted to do that, we could say that's 9M. Okay, so we have 9 Miss McKeachiks, and our variable is just 9M. So I'm going to put a 9 here. So we have 9 Miss McKeachiks. And let's say, we'll be nice today, so we want to add it, so it seems like they're coming together in their own little way. But if we look at Mr. Krasinski, our actor, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So that would give him, he would be 13K because last name is Krasinski. And I hope I'm saying that correctly. So this would be our final expression. And an expression is something that doesn't include an equal sign. So in this expression, we have two terms. We have 9M and 13K, and it's two terms because it's separated by an operation. And our coefficients are 9 and 13, and our variables are M and K. Okay, so we cannot combine this anymore. And that's kind of the sad part for Miss McKeachik. You can't combine those, so they're separated. They're kind of there, but they're not together. And they won't be, and that's an unfortunate thing. And, moving forward, let's go to our next example. So, our next example, still a real-life example. Let's talk pizza. All right, so in this case, if I look at these pictures, you should automatically say to yourself, okay, well, Mr. Frechette, I have 3 different kinds of pizza here. Well, yeah, you do. You have cheese pizza, you have pepperoni pizza, and you have my favorite, supreme pizza. Now, what does that mean? Well, in terms of like terms or combining like terms, I have 3 different things here. The cheese pizza can't come together with the pepperoni pizza. The pepperoni pizza can't come together with the supreme pizza, so on and so forth. We have to group them separately. So like I did in the last example, the cheese pizzas are going to be grouped together, and we're just going to call that variable C, right, for cheese. So how many cheese pizzas do we have? We have 1, 2, 3, 4, 5, 6, 7, 8 cheese pizzas. So 8 cheese pizzas will be, let's go down here a little bit. So this will be 8C, right? And we'll just we're going to add them together, right? Because we're going to bring them all together but separate. So that's kind of a weird way of thinking about it, but that's how you look at it. So we'll do another color just to show you that there's a different group. So our pepperoni pizzas, how many pepperoni pizzas do we have? 1, 2, 3, 4, 5, 6. We have 6 pepperoni pizzas, so our variable is going to be P. So we have 6P, so that's plus 6P. right there. And then our final pizza is our supreme pizza, which is my ultimate fave. And supreme pizza will be represented by the variable s. We have 1, 2, 3, 4. So there's only 4 supreme pizzas, but we'll still be adding those. So that's 4s. Now, like we talked about in the last one, these are together but not. They're separated by an operation. So how many terms are here? 1, 2, 3. How many variables do you have? Well, you have 3. There's C for cheese, P for pepperoni, and S for supreme, right? So we have 3 terms. What are our coefficients? Our coefficients are the numbers in front of the variables. Those are 8, 6, and 4. So 3 terms here. This is an expression, and we are done. We cannot combine these anymore because there's 3 different groups. So keep that in mind. Now, let's jump into our algebra example. So our algebra example is down here. And rule number 1, don't panic. You're like, oh, Mr. Bichette, what is this? So first thing we want to realize is what are our like terms, right? What are our like terms here? So what we're going to do is we're going to go through and we're going to highlight. So that's what I'm going to do. I'm going to highlight the like terms. And let's highlight the like terms in green. So if I look at 6xy, do I have another 6xy? I should, right? If I don't, it's okay if I don't. So we'll do green. 6xy, yes, I see another 6xy. So we have a positive 6xy. So those are together. And do we have any more xy's? We do not. So we have 2. So how would we combine those? Well, what's 6 plus 12, right? So it would be 18xy. So that's what you would have below. So below this, you'd have 18xy. And I'm just going to write that right now. So we have 18xy, right? And we'll write that or highlight that in green. Those have been combined. So you know exactly what that is. Now, we're going to look at our next one. We're going to look at y. So we have positive 8y. So we're going to highlight that in a different color. So let's go 8y. So positive 8y, we will highlight in, let's go yellow. Is there any other y terms? Yes, there is. It's plus 17y. So we're going to go to plus 17y. Let me highlight it first. So plus 17y will be in yellow. And now what we're looking at is, what is 17 plus 8? So that's 25y. So over here we're going to have plus 25y. So what I want to do is I want to highlight this in yellow because those are separate. Okay, so we have our green terms and our xy terms and our y terms. So now look, let's go down the list. We have xyz. So is there more than one xyz term? Of course there is. So if there's not, then you would stop there. So our xy term, our xyz term is right here. So we have negative 7xyz. And we're going to highlight that in orange. And then we have negative 9xyz. And we'll highlight that in orange as well because they're the same. We can group them together. So this is going to be a negative answer because negative 7 minus 9 is what? So, you know, it's okay to put it in your calculator. That's not a big deal. If you notice up the top of your head, you can. But sometimes when we deal with integers or negative numbers, we have issues when we go through that. So what's negative 9 plus a negative 7? It's a negative 16. So we have negative 16 xyz. So that xyz goes together with that. And it's no longer yellow. Okay, it is orange. So that now we have 3 different terms, right? But we're just combining the ones in the original equation. So that leaves us with one thing because we have green, yellow, and orange. They have all been combined together. But now we have our loner over here, our isolated term, the negative 14x squared. Do you see anything else that can go with that? Not at all. I don't see any other x squared around. So what I'm going to do is we're going to highlight this in blue. And that's just going to come down. That's going to stand alone. So what I'm going to do is I'm going to put this as blue. Now, down here I'm going to put 14 minus, and we're going to do a little insert here. We're going to insert our equation. Minus 14 well, let's do that again. So we're going to go insert. We're going to do our equation. And it's going to be 14x, and then we're going to caret it squared. So that is not an orange term, though, so we have to highlight that in blue because it's different. Okay, so you see your groupings by color. The only thing I want to change this to is standard form. So if I go below, standard form is this. So standard form is going to be putting our highest degree first. And that goes by exponent. Degree is exponent. So this has a degree of 2. So I have to put negative 14x squared first. All right? So negative 14, and I did it again. Mr. Frechette did it again. He didn't put his variable first. 14x squared. And I'm going to stop that. And what's our operation after that? So it doesn't matter what we do next. We could go xy. So we could go plus 18xy plus 25y, and then minus 16xyz. So that's algebra and like terms in a nutshell. And you can see they're all different. So if we were to just do one last highlighting, this would be blue because it stands alone. We combined, well, it doesn't look like I'm highlighting. So we don't need to highlight, but you can see the idea going down here. So we have negative 14x squared plus 18xy plus 25y minus 16xyz. So this is our final expression, and we can't do anything more with this. This is all we have. So keep that in mind. We have 4 terms. We have 3, it looks like 1, 2, 3. We have 4 different variable combinations. We have x squared. We have xy, we have y, we have xyz. We have a ton of coefficients, negative 14, 18, 25, negative 16. Okay, so there's a lot going on here. And this is a more in-depth problem. But hopefully this gives you the idea. If you have any questions, feel free to give us comments on Google Classroom. Talk to us in class. But have an amazing Wednesday, and we'll see you in class soon.